Combat. They say loving this music. Who is it? Well, you go on Spotify and you search the magic keyword DMCA Twitch free no takedown okay to stream playlist, and you'll get a whole bunch of lo-fi beats. This one is from Slow-Fi. You can see I have like a music tag at the bottom center of the screen, but they do a bunch of like sort of casual video game stuff, which is good for a video game stream. Cool. So just to give people like a little intro and what's up, I've started working on this like desert gym. We were working like a few weeks ago on like getting this like canyon run section going where it like kind of turns into Star Fox, and there's all these wasps that come out and are shooting you. I got a lot more to do on that, but I want to kind of like horizontally get at least all the elements of the scene like started and in before I really dive deep on any specific detail, just to kind of like block in the full scope. So I'm also working on this like sandworm. You can see I already got started this morning. I'm just kit bashing this together with like shapes, but like I wrote a special controller where you can move the head and then the body follows, and I can like drag it around real quick to show you what's happening. It's actually recording the motion path, right? So this white line is the path, and then the head, it just like positions all of its spines sort of like along that path. Retrospector says, hey yo, hey buddy. So yeah, we kind of like save all these breadcrumbs, we align the spine to the breadcrumbs, and then I also, for the rotations, I orient them like sausage links along it, and then I'm also doing a kind of like, this is a rotation minimizing frame propagation, so each link is specifically rotated to be like as little twist from the one before it. That's pretty cool because it means if we're like going upside down, you won't get like a kink right here. Instead you'll see it'll just curl over, and then when we come back around the bottom here, it'll write itself back out again. But if it's stuck upside down, it can always just like twist the head. So this is kind of like, this is pretty good in terms of like positioning all of these links, but you can see I'm still just dragging the head around with my cursor. It gets a little weird because I'm not rotating it as I'm dragging it. Also, I can drag it with like paths that have more detail than the sausage links, which can cause them to get kinked up. So there's probably like a minimum curvature that it can like acceptably do like in like the real game. But then additionally, so I think what I want first of all is to basically make a root motion controller. So I think what I'm going to do is I'm just going to put a big spline, you know, kind of like how over here we just placed a spline for the camera to follow in the canyon. I'll place another spline which will just be the horizontal movement of the worm. And then it will basically, I'll set it to like oscillate above and below that spline. So like, it'll be like, go under, come up, go under, come up, you know. And then once we've got that, we can basically sort of like spawn in an actual player when it's moving and grooving, and we can see like, does this scale make sense? You know, should it be bigger, should it be smaller? Before we like really drill down and start to think of the sort of details. I think this is one of my first like, I think all the characters in the desert are going to be like, there's going to be this worm, but he's going to be kind of like more an insecty worm and not like a dune worm. I think everything will be kind of insecty. We have these big wasps in the canyon. We that's my idea. It's the planet of giant insects. So yeah. So what we need to do is we need to make a prop, which is the spline that we'll lay out, and then we need to update at the root of this character is a blueprint that I have called Mecha Wurm. This is not really going to be a mecha, it's going to be like an insect, but mecha is my word for like all these like level scale characters that are made up of multiple actors. Like I also call spaceships mecha. So yeah, we'll make like a base type then, which is like aware of the spline, has a little state machine, and one of its states will just be to like follow the spline and oscillate. I think that'll probably be like good for like a 2-hour stream, but what I want to do next, and maybe I'll just draw this to sort of show people where we're going to go, in case you follow along on Twitter and start seeing stuff. But I'd really like to do something where like, so like we've already got it. Let me just burp. So we've already got it where like it records a motion path, and then it like lays out a bunch of sausage links along that breadcrumb path, right? But that can't really like strafe or do other things. I would like it to basically be able to be like, you know, there's like here's the ground, and then like it comes out of the ground, right? And then stops, and then like, you know, this sausage link right here gets like fixed in place. All of these, we like don't move them, they're all fixed in place. But then all the links above here, I will do a switch from like following the breadcrumb path to basically being like an N-bone IK chain. IK stands for inverse kinematics. It's when basically, you know, there's like a lot of things like this, but it's basically, you know, I have 2 points and I move the 2 points around, and then it just figures out how to like align like all the sausage links in between them, and that'll let me do here. I can actually, let me see if I can look this up. There was a prototype that we had at like Heart Machine a while ago where we were doing something similar to this. Looking in my is it this? No, it's not this. I think this is it. Nope, that's not it. Yeah, here we go. So like we had sort of prototyped these eel enemies. We didn't end up using them for Solar Ash. I don't know if they got used in Lightbreaker or not. Prototype's still lying around in a hard drive there for somebody to steal. But yeah, it's just this idea of like you've got one thing pinned in the ground and one thing pinned for the head, and then you can basically do AI on the head and it'll just figure out all the links in between the head and the ground. So I think it would be cool if the worm can like come halfway out and then switch from the breadcrumb to that like IK thing where it can like strike down at you, kind of like a jugfish coming out of the sand. I don't know if people know what jugfish are. I'm going on so many tangents right now. Here, I'll show you real quick. YouTube.com. Jugfish. No, not a shark. These are little tentacle guys. Wow. YouTube's just like totally failing right now. That's weird. I'm not crazy though. Maybe I'm crazy? These are the little long skinny fish that like bury themselves in the sand. Skinny fish buried in the sand. Like a weaver fish. I'm gonna go crazy if I don't find this. Here they are. It says sandworms at the Okinawa they're not sandworms. I could have sworn they were called jugfish. It says they're called garden eels. Is that what it is? Anyway, you can see these cool guys. So yeah, like we can do something like this where it sticks half out of the sand, and then like you can like look around. And then if we want to switch back to movement, we can just record its current pose as the like initial condition for a new breadcrumb path, and then start breadcrumbing again. So we should be able to do this switch between the breadcrumb mode and the IK mode, and then it will have like when it's in its movement states, it can like move around the map, and then when it like comes halfway out and like IK switches, then it can go into like attack mode and like stab at you, and then it can like go back into like breadcrumb mode and then keep traversing to somewhere else. So I imagine this is kind of like a reverse escort mission where like you're chasing it and then it stops and then you fight it, and then you're chasing it again and then it stops and then you fight it. And like maybe there's various points where it like goes through an area that's gated off to you, so then you have to find a way to like blow up the gate and then continue pursuing it, right? So there can be like a lot of like little side distractions in the desert level, but the main thing that you're focused on is chasing this big worm. So cool beans. Let's get back to it. So like I said, first things first, I need to make a spline path prop. Then after we have that spline path prop, I need to make an AI controller that follows that spline path prop. And then I'll make the AI controller basically project the spline onto the ground, and then I'll have it oscillate above and below the ground position. And then we'll test. And then I predict it will be a quarter to 4 at that point. But maybe this will be really fast. Who knows? So cool. I'm gonna close Unreal real quick, and then we're gonna go into Code World. Hopefully this wasn't a little too long and rambling. Sorry for the 2-week break. We were at GDC, doing GDC stuff, trying to find some partners for the project so that we can bring it to y'all. It was really cool. Shout out to anybody else who was at GDC and got to play the demo at any of the exhibits we did. Yeah, as always on these streams, it's like open, ask me anything. So if you're in the chat, just like ask any questions. I'm perfectly happy to like put a pin in whatever I'm doing and either like show you another part of the game or like just answer general questions about like game development or programming or technical animation or anything like that. So cool, I'm gonna go mute my microphone and start writing code. Thanks for watching. like saying the song Take On Me is from The Last of Us Part 2 soundtrack is a little bit of a stretch. That's video game music, but I don't hate this cover. Just to sort of fill anybody in who hasn't been here if I've done like any AI program before, but the way that I usually code AI, just because this is the way I've been doing it since literally the 90s, is basically to have a single, like usually when you're making these classes that are like, oh, the Wurm is a type of mechapawn, you have these virtual functions, which is like, oh, I want to override the default behavior with some special behavior. So I create a single virtual function called handle event. And so these events are things like I'm entering a state, I'm exiting a state, I'm updating like one frame, or like I've taken damage or something. And then I have this event switch helper method, which combines a type of event with the current state that I'm in, to create these kind of like combined IDs, right? So the spawning enter ID, the spawning update ID, the wander enter ID, right? And then I can just write one big switch to basically say, what should I do for any given event for every given state? And like this is pretty nice, like on the code side, because like the header is really small. You basically just have one function instead of a bunch of virtual functions. It also gives you a lot of flexibility. Like I can mostly put all my AI logic inside this big switch, but I can also have like some branches before or some if else branches afterwards if I want to like have a bunch of states handle the same event the same way or whatever. And like usually a lot of times you like turning something on when you enter a state and turning something off when you exit. So it's also nice that like the symmetric code like that for enter and exit can be like close to each other without like a lot of stuff in between. I can even like reorder these. I can put like enter and exit right next to each other, right? So all we really want to say is when I'm in my spawning state, I'm trying to figure out my initial state, and like if there's a spline, then I should transition to my wander state, and then in my wander state, if I'm like missing that spline, I'm gonna like go back into my I don't know what I'm doing spawning state. Otherwise, in the update, I'm gonna advance forward along the spline and then up and down in the oscillating pattern. So first thing we got to do is I've made this type for the spline, but in here we need to actually reference it. So this is a U property. That basically just means this is going to become a drop down in the level editor that will let me pick any other actor in the same level that has this signature, right? Like its type is that it's a Megapon Wurm spline, which we've defined down here basically is just a thing that has a spline component. We might add some additional helper functions here that go above and beyond what spline does on its own, but for the most part we're just going to be using, this is just a wrapper for this spline component. And then the way my state machine handlers here work is when you want to change state, you just return the name of that state, and then it will rerun the handle event function, but with that new state, right? So that's pretty nice. It means that like updating states and transitioning states are kind of handled by one piece of code. Keeps it a lot simpler. So I added a bunch of like parameters to the Wurm spline, like how fast should you go, what should the amplitude and frequency of your oscillation be. I think this belongs on the spline and not on the Wurm, because I'd like, maybe there's like different splines and you have different speeds or amplitudes on different ones in case you like go from one to another. Hello, final turn. Sorry for all the code for everybody who maybe is just checking in. We're just doing a real quick thing to make a big worm go in a loop, and then we'll be back in the engine to start looking at it and tuning it and seeing more fun stuff. But yeah, ask me any questions you have about making games in the meantime. Took the music down a little bit. Is this a little bit better? It's saying that I'm coming in at negative 15 decibels and the music's coming in now at about 30. So that should be twice as loud, logarithmically. I don't know how audio works. Thanks for the feedback. You know you're really doing math when you have to whip out pi. Just in case people who didn't enjoy algebra class or trig class in high school, pi almost always just means 180 degrees. Like flip it around, you know? If we're going around the spline backwards, we need to flip that direction around. So in Unreal, when you make like a native type, like here how let me find it. Oop, no, not that one. No, you go away. Oop, so many windows. Like when we make this type, Mechapon Wurm Spline, the way you hook that in the engine is you make a new blueprint and you choose this like class picker, and then you just type in. You won't need to type in exactly just a few keywords into this filter to narrow it down until you can select it. Wurm Spline. So now you see this is auto-populated with a spline component. Which is what we did in this constructor way back here. We're like, hey, we want to have a spline component, we want it to be called spline component, and we want it to be the root. Bada bing, bada boom, we have a spline component. It's called spline component. It's at the root. It's inherited, which means it comes from whatever class is in the upper right hand corner. Splines by default in Unreal are like tiny though. Look at this, it's like 1 meter, like a little straight line. So by default, this should probably be something bigger. I'm thinking like a circle. One of the advantages of labeling a class as an abstract base type and then setting it up in the editor here is any like defaults. You can just use the like interactive things of having to know exactly what to type in C++. So. Kamoho asks if the worm is going to be mechanical or organic. So in this desert planet, I'm thinking of everything as being like insects, so it will probably be more organic, like with a carapace and stuff. Although the idea is that, and I mean like you can see this sort of suggested from the fact that I'm descending from the mecha base type, is that any of the pieces that I make for insects, for giant robots, like the kaiju-sized robots, and for spaceships, are like freely interchangeable. So like, I kind of like the idea that like, you know, we're gonna have some like organic wiggly tentacle parts that will attach to the worm, but then that might also be like a mechanical themed tentacle on something else, right? Or like this kind of thing where I don't know if you saw earlier, I'll show this for people who are just tuning in. This is our current status. We've got this kind of like base type thing, kind of like the dragons in Breath of the Wild, where it follows like a path that is recorded as the character moves. And like this sort of thing can also be used elsewhere. So like I'm trying to think of like other mechanical things that might also benefit from having that type of movement. But you know, as you can see right now, I'm still just dragging this around with my mouse cursor. So what we're setting up is a path, and it will automatically follow the path, and then I'll make it automatically like go up and down and oscillate. And then once we have like a bunch of collision shapes moving around in the level, we can actually start spawning in our characters and see how it feels like action-wise to actually like crash into it or land on it or fly around it, and then we can get that feeling good before we like go too far down the rabbit hole of giving it like combat AI and stuff. It says, because I had this thought for the longest time of a mechanical snake or worm type creature that had cannons on the side of its body and would broadside you while you're circling. Yeah, I mean, like I've got just to show like one of the reusable mecha parts we have from the cruiser. Yeah, is these cruiser turrets. But like I can attach these to anything, right? So I can come in here. I can say attach to, I'll use a little eyedropper and I'll just say attach to this, right? And then if I spawn in my player, you can see I can do that. So yeah, the only two like attachable weapons we have right now are this turret, and then we also have like a mecha head, I think is in the spider. Yeah, this mecha head. And this one does like big charged shots. It's like bah, 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 and then it shoots out a big fireball. And when the fireball hits the ground, it's a big AoE. For most characters, it's like a one hit. So like that's sort of the idea, is like I have a bunch of these like prototypical things, like big spider, big spaceship with a bunch of cannons, big sandworm. And then we can like mix and match parts. Like I've been on too many projects where we made like tools that were like really cool for remixing stuff, and then you know we only ended up making 6 or 7 like actual characters, whereas like with this game I want like just encountering more wild giant things to just be part of the texture of the game, right? Like, you know, in Mega Man, you're constantly encountering Mets and their little guys, and in this one, you're just constantly encountering spaceships and giant robots and stuff, so. And like giant insects and things. I'm going to take a little diversion right now and show you one of the other insects we were working on. This one's like a big scorpion, right? So this will also be in the desert. I gotta art it up a bit more, but kind of the idea of that is that like this tail part here, like it could use a lot of the same like components that will go into the sandworm when it's like sticking its head out of the ground and looking around, and it might shoot you or like smash into the ground. Scorpion's tail could do the same thing. So, you know, we write one component, but then we use it in a lot of different places with a lot of different themes. So this empty actor right here, this is the IK controller for the Wurm. The way that I build these like multi-actor characters is that there's like an IK controller at the root, and then all these components you can see are like nested under that IK controller. So it's basically the brain, and then all these pieces are all the parts of its body. So what we want to do is we want to reparent this blueprint. Instead of being a generic mecha pawn, now it is a mecha pawn Wurm. Save that. And when we go back into level now, you can see, like I said, We added this U property that was of type Mecha Wurm spline. Now here it is, and we can pick that spline. Kamo says it's going to be more common enemy or a boss. We've got 1 gig in mind where like there's like a giant sandworm, and it's like a reverse escort mission where you're chasing after it as it moves through different parts of the desert environment. But then I think there will also be lots of like small and medium-sized ones. And then, you know, later on when we start like really going crazy with the remixing and having stages where like lots of crazy stuff is going on, there will probably be like more of these, you know, I could imagine like a spaceship or something that's kind of like a worm. So you'll also see them like, you know, reskinned as spaceships and things. Okay, moment of truth. I'm going to hit play, and if everything is correct, it's going to start following this path around. So let's see what happens. Hey, look at that. Oh, by the way, I also want to use this technology to make a train. I'm like a train fanatic. This is a secret excuse to make all the programming that I'm going to need to make a train. So that'll be fun. Also, like semi-trucks with lots of like tractor trailers behind them, kind of like in like space ones. Like what's that episode of Cowboy Bebop where there's like space truckers and there's like Victoria. Wait, what is it? Cowboy Bebop truckers. Boop-a-doop-a-doo. Show me the trucks. Retrospector asks, have you heard of Shinkalion? It's bullet trains that become mechs. No, I haven't heard of that. I know that there's several like tokusatsu things, like Power Rangers stuff that have a train theme, and they have like railroad track sashes. Usually when I think of trains in anime, I think of Galaxy Express 999. Here, we can check Galaxy Express. This is just like train in space. So the worst images. DuckDuckGo, what are you doing to me? Here we go. Look at that. Space train. It's great. Okay, so we're doing pretty good. We're at like the halfway point, and our worm has a state machine. It's got a spline. Right now it's just following the spline exactly. You can see like these ones on the back. It's like the spline is coming out directly. So I think the two things, the next thing I want to do is like, instead of following the spline exactly, I want to cast a ray down. And like aligned to the ground, so that like as it's traveling around, even like level designers don't have to position this exactly on the ground. Like it will figure out, like it will like cast a shadow down from the spline onto the ground, and then it will follow that shadow instead of the rail itself. I'll just go through here and explain all the code that's happening right now. If the spline disappeared for some reason, then we're just going to go back into our I don't know what I'm doing state. Otherwise, we save off an alias for that spline so we can just type S instead of typing spline component, which is very redundant. Then we advance the distance in our spline direction at the wander speed based on our current frame time. We wrap it around. I've already assumed up here that splines are all closed loops. We could handle a not closed loop by having it like do a flippy flop and turn around, but that seems like a little too complicated to make for a good screen. I almost said a good screen, a good stream. So now we're basically just like, yeah, if you go less than 0, you've sort of reversed past the beginning. So in that case, we want to like wrap you around to the end. Otherwise, if we've gone past the end, right, then we want to wrap you back around to the beginning again. That's all this code is doing. And then we get the anchor, right, which is just we sample the spline and we get a transform, right? When we say transform, we basically mean something like this, right? Like something that has a position as well as all your different orientation axes, sometimes called a matrix. And then, you know, if we're reversing, we want to flip it around. That's what pi means. Pi means flip. And then I'm actually updating the pose, right, of, in this case is the pose of the head, because that's where I've like positioned the head. So we're going to update the pose to be right on that spline. So what we want to do next is cast the anchor, yeah, down to the ground. Now, down is a little extra complicated in our game because we also have moon gravity, where like it wraps around and the gravity is always pointed towards the middle. So it's not just going to be like straight down. We have to like know like at our current position like what is the gravity. And my mecha, I already made the spider when I worked on the moon base be aware of gravity, and I added that to the mecha base type so that everyone can access that. So to do that, I can just say get up dir at position spline anchor location. Gamaho says, when I play Satisfactory, getting a nice train track going is one of my favorite activities. Nice. I really want, we're really on Train Talk now, but Nintendo Switch Japanese train controller. It's obnoxious because there's no American games that use this. They have a straight up, what is this? The Get a Train Go controller for playing these like commuter rail simulations, which are basically just excuses to like look at different neighborhoods in Tokyo. It's so silly. I know that like if I actually had this, I would get bored of it in like a week, but I like to fantasize that actually my whole life would be better if I had this. Okay, so we got the up direction. In this case, it's just going to be straight up, but if we were on a moon, that would be like away from the middle of the moon. So to cast down, we want to say So we're going to cast from a position slightly above the spline to a position slightly below the spline, basically. In this case, I'm only tracing against the static environment. Bibney says, ASMR keyboard, hello. I'm glad to provide this unintended service. But we're only tracing against the static environment because normally you don't have to worry about traces hitting yourself because you normally ignore yourself. That's what this keyword is doing right here. But in the case of the worm, it's made up of several actors, so you know, I don't want to have to go to all the trouble of doing all the actors. I also don't care about aligning to other moving objects. Like if there's a truck below me, I would like the trace to go through that. So I'm just tracing straight down to the static environment. Launching our level editor. Boop, boop. There we go. So now, here I'm going to adjust this headpiece. So now, the nose of the head of the worm is like right on the line. Bimini says, oh me, I just realized this was Unreal 4. That's right. I decided to stick with the stable version of the old engine rather than jump on Unreal 5 because it's still kind of in a treadmill of updates. And I just really hate having to update engines. So I'm gonna wait until that's way more advanced and then maybe I'll update. Or maybe we'll just ship this game on Unreal 4 because it's a perfectly cromulent engine. But now, since the nose of the worm is right on this red line here, that means since we're casting from the path down onto the ground, its nose should basically be touching the ground. So, whoop. Yep, there we go. So this is nice. You can see, like, even if the level designer goes in and makes one of these a little too high and one of these a little too low and accidentally clips it through the ground or whatever, like, that doesn't matter. It's very forgiving. It's just like putting this worm like right on the ground. So that little up and down, it's like ignoring that. And then this little down bit right here, it's like ignoring that. We're just aligning perfectly to the ground. So at this point, I'm going to do like a quick test and see what it's like to actually spawn in here. Nope, nope, that's not what I wanted. Nope, that's what we want. That. Well, that's really cruising. Slow that puppy down. So if you recall, we put all the speed parameters on the spline. Clicking that spline was really annoying. What I'm gonna do, he says, that's really cool. Thanks, I think so too. Nope, that's not the piece I wanted. I wanted to look at Wurm spline. So I'm just gonna add a billboard. Pick one of these icons here that seems fine. That looks fine. I'm going to say editor only. That will strip this out of package build to the game. And now I don't need to click on these tiny little knots. I just need to click on this icon and I will get the worm spline here. So then we can, yeah, here we go. Here's all the worm settings. You can see the speed was like 10 meters per second. Let's make it like 5 meters per second. Just have it. How fast is that? What happens if I get out ahead of it? Or I just get like scooped up by it? That's fine. By the way, I'll show you, you can see there's this debug material that I have on here that's kind of like silver on the top but red on the side. This is, it's a little wonky because these aren't like aligned like these grids are, but it generally has like grid markers so you know about how big things are. These are about 1 meter a piece. But then also it colors it based on whether the surface is walkable. So this blue area right here is like all walkable, but this like red area is not. If I like grab this, oop, that's not what I wanted. Yeah, if we scaled like this, you see there's like a certain point. Maybe not, I don't know. Maybe it's doing it all in local space, but like if you like flip this guy sideways, you can see this is walkable and this isn't. So that's just like in this like prototyping phase, that's pretty nice in terms of like being able to get an expectation of how things are going to behave with the character controller before you actually play. Bibney says, I had the same kind of material in an old project. It's super useful. Like, you know, I think like Unreal and Unity and other game engines, Godot maybe make it real easy to just like whack play and test stuff, but like I grew up in an older time when it was like real pain in the ass to actually get the game started. So the more that you can just like see before hitting that play button, I think it's just the more efficient you are. So. Anyway, Bumi says I will definitely mention it in my new company. It's really missing. Yeah, it's one of those, I don't know, like I have a tools background, and so I always think like giving people better tools is always great. I always also think of stuff in terms of like the number of clicks. Like if I was a level designer, how many times do I need to click to do something, right? Like ideally you should only have to click like once or twice. Oh, we've got the boy. Here we go, let me update the label. Hey buddy, what's up? Specializing in AI programming. I still have so much to learn. Is that like AI in the sense of like characters making decisions, or AI in the sense of like hype tech stuff from Giant Megacorps? Digging into State Tree and Mass Entity, which are the two new Unreal frameworks. Yeah, those are pretty interesting. We used whatchamacallit, in the prototypes for Hyperlight Breaker, it was all Blackboard. So that's basically just like a decision tree, or a, yeah, that's what it's called, right? Well, it's not like a state machine, it's just like a hierarchy that you descend to until you like hit your current state, and then you just stay in that state as long as it keeps evaluating it. That was pretty handy. I was showing a little bit earlier. Where is it? Oh, you're talking about, yeah, that was it, behavior tree. Anyway, I was talking a little earlier about how the way I'm doing AI is I just have this single handle event like override in which I combine your current state ID with the event ID into like combined state transition like IDs that can just be put in one big switch, right? So you can see I've got my like spawning state here, enter, update, exit. I got my wander state here, enter, update, exit. So you can see, like, I'll show you like a more elaborate example. This enemy commander was a mini boss that I wrote, and you can see he's got like a bunch of like states. So there's like idle, wander, aggro, the anticipation for the barrage attack, the cooldown from the barrage attack, the anticipation of the missile circus attack, then like his killed state. So there's like a bunch more stuff that I need to add here. But, oh, you're trying. So basically, yeah, this is just a finite state machine. But I've got like a bunch of like plumbing taken care of to make it easy that like in this handle event function, if you return a non-zero number, like basically a state ID, then you'll like exit your current state, enter that state, and then rerun the event on that new state. So the transitions are actually a lot easier. This is a technique that I learned actually when I was working at Yacht Club games. Like this is basically the way they set stuff up in Shovel Knight, and it makes it, if you're writing all your AI in C++, this is about as picky as you can get it. So I like it. I've been doing all my gameplay code in C++. I haven't been using Blueprint for it just because like it's sort of like Blueprint's kind of slow, and it's also like hard to keep the complexity under control. So I still use a lot of Blueprint, but it's just for basically like sound effects and VFX and very simple like scenario scripting. We're actually using a plugin called Logic Driver by Recursoft. I mean, if you're working with designers, this is like kind of indispensable. It's ridiculous that it's not actually part of Unreal, but here I'll show you like FSM DMV. This is it's basically like the animation state machine, but you can do it for game logic and you can make custom states. So this is the whole scenario script for our like tutorial, right? And you can see there's like wait for states, there's like dialogue states, and then there's like custom states, right? So like, oh, here we're teaching you the weapon swap. So here's what you do when you enter that state, here's what you do when you exit that state, and here's the condition in which you exit that state. So this is pretty handy. This is all very designer accessible. So this is our combined like, you know, level designers lay out the level in space, and then this is going to lay out the scenario in time. And this is also like where the writers have access for saying like, oh, I want some dialogue, and this is the speaker, and these are the people who are showing, and oh, I want to use a custom emote texture or whatever. So it's just like a very simple and straightforward thing. And you can like debug this the same way you can debug an animation graph. So you can just like see it highlighting like, what state am I currently at? And then there's like a little bit of junk up here, which is just me making a bunch of shortcuts for like testing different parts of the scenario. So this is our like scenario editing tool. This is like the most Blueprint we're doing. But for enemy AI, I keep it in C++ mostly because like, you know, there's like so many enemies in our states, right? Like even in the moon base, which is not a big base, like there's like a dozen tanks, there's a dozen jets, there's 2 cruisers, and there's a giant robot. So, you know, that's all stuff that like I prefer to just like keep in code, like both because it's easier for me to maintain if it's just text files and not like Unreal binary files, but also it's just easier to profile the performance and fix it if you have like a big squad, as opposed to like blueprints where you end up having like a million little ticks. So all just experience from having worked on some bigger Unreal projects. But yeah, I will get back to actually working because we're coming at the like 3/4 point. So I at least want to get this guy going up and down. So let's start adding the oscillation. Bibney says the mass entity is completely reshaping how we deal with characters as an entity component system architecture. I'm a I'm a well-known entity component system architecture hater. I think it's a kind of like a bit of a cargo cult. Like, I think it's fine, like, when you're doing a problem that it's good for, but I also think people use an ECS once and then they're like, everything should be this way, and anybody who isn't doing this is actually an idiot, and it becomes really hard to talk to. So that's pretty cool if it works, but, you know, I think it's kind of overblown. I don't know. I've been doing object-oriented programming for 25 years, and I've never had a problem even working on, like, big AAA games. So, go figure. Tangent programmer talk over. Now we're gonna go here. Let's do the oscillation. So, so when we enter our wander state, let's reset the spline oscillator. Bivney says, I splitted which architecture I use for the different AI that I'll implement. Yeah, I mean, it's just a thing which is like, it's good to have a tool belt with like a bunch of different tools and then to just pick the one that works the best, you know. In the case for like Nightshift Galaxy, I'm the only programmer, so it's easier for me to just do it all in like C++ files. Don't have to like accommodate like processes that would overcomplicate things. Retrospective says the two situations where I've heard ECS is handy is you have a lot of entities and you want something state is easy to make deterministic. I haven't tried myself though. Yeah, I've heard like basically like 3 versions of like when you should use ECS. Like one is like essentially like the NoSQL, like I don't want to have a schema, I want to just be able to put stuff together at runtime. Another version of it is like the performance one, which is like, oh, you've got thousands of objects of the same type and you would like to co-locate them in memory in a system, as opposed to splitting them out like all over the heap and then sort of bouncing all over, like chasing pointers in your update. And then there's the other one, which is like, yeah, if you basically want your data to be tabular because you're doing some kind of like functional programming that needs like rollback in a certain way. So if you have those problems, that can work. But like, yeah, for Unreal, they've already built replication in like in an object-oriented way at a pretty low level, where like every single actor is like a different replication channel, as long as you like enable replication for it. So I find it easier to just use what the engine's already doing. And then yeah, as far as like not chasing stuff all over the heap, you're kind of stuck with it, right? Because you have like actors in Unreal. In theory, if I had like huge Zerg rush enemy, I might like refactor that in an ECS style or whatever for the like data oriented way, where like maybe they have some hot data that's in a compact array. But I think you would still access them through the normal actor interface. But yeah, I don't know. There's a, what is it? I'll at least plug one ECS system that, wait, what is it? My friend Evan maintains. He's working on Samurai Gun 2, and they're using it for that, and they've liked it. So I will continue to promote good stuff, even if it's like not my cup of tea. What was it? Was it like moon or... Totally blanking on it. Let me search the other Discord for it. Yeah, here it is. It's called moontools.ecs. So if you want to play around with a C# one, this is mostly built around doing mono game based projects. So yeah. Back to regularly scheduled programming. So we're doing an oscillator. I always trip myself up. I shouldn't get tripped up by this simple stuff. Uh-oh, I think the boy's about to leave. We no longer have cat detected. But you can basically just think about this in terms of units. So like delta time, that's in seconds. Frequency, that's in oscillations per second. So seconds times oscillations per second is the number of oscillations that you performed. So then oscillation angle is 2 pi times the number of oscillations you've done. Sine is your basic like oscillation function. Sine does an oscillation every 2 pi. So you do 2 pi times the number of oscillations. And then we add on the spline the amplitude. So just gonna push it out here. Target position is going to equal our ground position plus our up direction times our oscillation. And then this damp position, this actually updates. I mean, this is like basically chasing this target position with a latency of, here 0.1 seconds. That's kind of like a low pass filter, but this ends up updating both the position and the velocity. So previously we just oriented the character just to the spline, but now like the spline's forward, but we're going up and down. We want the nose to actually pitch up and down. Bibney says, should it clamp the position.z to the ground? Well, what we did up here, this may have been like literally 5 minutes before you came in here, but we get the current up direction, which is important because we also have moon gravity. And then we do a terrain cast from slightly above the spline to slightly below the spline to figure out the ground position. And then, yeah, that ground position, if we have a hit, it's the hit, otherwise it's the spline. So then this target position, we're taking the ground position, plus that up direction. So, you know, if our gravity's sideways, that up dir is going to be sideways rather than up and down. So I don't want to actually touch dot z, because gravity might be along the x-axis, who knows? So we're just using this up dir times the amount of oscillation. And I had a typo, I meant to say oscillation, not spline oscillation. So yeah, now we want the rotation, instead of just pointing along the spline, we want it to like go up and down. So I think what I'm actually going to do is make a rotation out of the up direction and your current velocity, so you'll just be facing in the direction of your velocity. All these little util namespaces, these are my own files. Even he says, I've never seen using namespace. Yeah, it's pretty handy. Like, you can do it in any scope. So, you know, you can put it like in braces and it will only be in the scope of these braces. This does it for the whole function, but yeah. I just hate typing util all the time. So like, you know, in my spline, like enter code, here I've got like find closest to world. This is actually spline util find closest to world. So it just keeps, I like keeping my like inner, like I have a bunch of these, like handle event ends up being like a really fat function. Like by the time this Wurm, we're done coding it, right? We've currently hit about 100 lines. It's easily going to be 1,000 lines in the final game. Boomy says, does your utils are static library? They're just freestanding C++ functions, right? So you can see here's all my like rotation utils, right? And they're literally just freestanding functions in a namespace. Like I started in C, not C++, so I'm actually more used to just having a bunch of freestanding functions, like, and not always putting methods in classes. So there are a few, like I do have like star function library and like fire function library, but I only expose stuff to blueprints as I actually need it in blueprints. I don't expose anything to blueprint if I don't need it. But like, yeah. So quad util, quads for quaternion. Quaternion just means like an angle axis rotation. So these are just all my helper functions for working with freeform rotations. And then down here, I just use my from xz function, which is I'm going to supply you two vectors, the x and the z, and you're just going to point in that direction, right? Always make sure the z is up, because you need two vectors to construct a like a rotation. The reason you don't need three, even though rotations actually have, if you see here below, three vectors, it's because you can always use the cross product dink to figure out the third vector, as long as the first two are like linearly independent, we say. So, and the only difference between xz and zx is, do we point in the x direction and then align z, or do we point in the z direction and then align x? So in this case, I definitely want to point in the direction of the velocity, and I want to be upright. So that's what those arguments mean. We pass it into a low pass filter on the rotation, and in this case it's pretty simple because it's just a simple rotation where you're just like up. But you can also, whatchamacallit, like what am I trying to say? You can also like once we're on like moon gravity or whatever, like the Wurm will be able to go all the way around the moon, and it will be upside down when you're on the bottom of the moon, and it will be sideways when you're on the side of the moon. I made a game with player-controlled creature that will crawl on any surface. The bot saved my life. Yeah, we've got, here, I'll show you once I get the thing going again. But we have a spider tank, and the spider tank can climb walls. So that one's a very kind of like unique character controller. Yeah, here, I'll change over to the spider. It's the commander. It's the name of the pilot. And then... Oh, look at this horrible oscillation. I mean, it's working. It's just... what you're seeing here is that the frequency of the oscillation and the resolution of the sausage links in the character are like the ratio of it is below what's called the Nyquist frequency, which means that it's not doing a recoverable reconstruction of the curve, and so it's producing all these artifacts. So let's actually change that. So we want that, instead of doing an oscillation every second, we want to, or we do one, the frequency is we're doing 1 per second, right? We want to do like maybe 0.1 per second, and we maybe want 100, 150 meters. It seems too high. Wait, what was my default number here? Was it? Yeah, it was doing 5 meters. Let's do a 15 meter amplitude. So I'm just going to simulate. So now he goes up, he goes down, and then he's gonna come up again after a hell of a long time. So now, okay. Oh, that's what you're asking about. Yeah, so this is like a sandworm, right? So it's supposed to go in and out of the ground. That was the idea of my design here. Dune 2 intensifies. Yeah, that's why when I was tweeting about the stream earlier, I was like, this is going to be oddly topical. Also getting Chinese dragon vibes at the moment. Yeah, this is totally like the same kind of algorithm they used for the Breath of the Wild dragons. Also, the one we used for Ouroboros in Solar Ash. Wait, I can show you videos of that. I was pretty proud of that. Let's see. Solar Ash long play. Oh, this is the very end of the game. So, in the opening section, yeah. Let's get to the actual combat encounter. Okay, here we go. Look at this guy. Look at this big dingus. Boom, goes around, and then we set it up so that like it kind of hangs out a little bit above the ash cloud, and then once you mount it, it actually like ascends to make the fight feel more dramatic. So you can see phase 1, it's like a little bit higher than the ground, but I think in the future phases, yeah, it gets even higher off the ground. Ruby says, did you work on Solar Ash? Yeah, I did the principal gameplay programming. So, you know, in this scene, I did the big level skill character, I did Ray, the like player character, and then I did the camera, as well as all the like setting up the crazy gravity and everything else. So, a lot of these ideas in this game are like, I wanted to go crazier with stuff on Solar Ash, and we had to be kind of conservative, and so like I'm interested in kind of like peeling back a little bit. So anyway, like I think the way, because these things were because the oscillations are aligned to the ground, B says, I finished Solar Ash 1 month ago, I think. Ah, thanks for finishing it. I finished it on the easy mode, but I was not able to finish it on challenging difficulty. Luke, who was the designer on all the remnants and a lot of the combat encounters, is a way better gamer than me. I was like, oh, this is too hard. Anyway, I think what I'm going to do is I'm going to like offset this off the ground a little bit, like we might move it up. That way you'll see like more of its body above the sand and less of it below the sand, instead of seeing only exactly half of the path. So let's add a parameter for that. We'll call it wander oscillation offset. The target position will be spline wander oscillation offset. Whoop. Plus the current oscillation. Yeah, Solar Ash was a real blood, sweat, and tears project. We were really punching above our weight. I think people thought we had a much bigger team than we really had, but I have the personal distinction of setting up the Perforce Depot and making the first check-in, and then fixing the last bug and making the last check-in right before Goldmaster. So I have a lot of personal affection for that. Retrospector says, how many folks were working on Solar Ash? It ramped up over time, but originally there was just, you know, me and Alex and Sean, basically. And then more and more people came on board, and other people rolled off of Hyperlight Drifter and came onto it, like our art director, Cosimo. So we hit a state of being about a dozen people for a few years. And then as we entered like alpha, I think there was like another dozen like contractors who came on to help us final all the art, cubing things and stuff like that. I heard the Unreal AI team was only counting 6 people. Yeah, Epic is quite strange. I don't understand it sometimes. Like, I mean, granted, you can't like make things better by throwing more people at problems, but also lots of features are usually maintained by like count them on one hand, like number of people teams, which ends up exposing yourselves to a lot of just like the biases of the individuals who are working on it, rather than the people who might actually be using the feature. So, you know, I'm still a little steamed that Unreal uses variable ticks for gameplay and doesn't have a fixed tick, but what can you do? Okay, whoop. I added that feature, but I didn't use it. So we want oscillation offset. So it's going up and down 10 meters. So if we go up 5 meters, then you should be mostly above ground, but then do these little dips underground. Let's take that down. Maybe like a third of the amplitude. This is looking pretty cool. Thanks. I think the thing that I want to check next is like, I might want to check the curvature of the spline, and like if it's curving to the left or the right, maybe the character tilts left and right. Yeah, that might be cool. Let's see about doing that. So, we come back in here. Do a barrel roll. I can do a barrel roll. Let me show you. Bakading! 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 Oh, jeez. Wait, can I fly through? Yeah. Oh, yeah. Cool. Oh, I never showed you the spider. Let's see what the spider looks like on this. If you can, like, cling up to it. There. Oh, jeez. Let's cling to the head. Ah! Okay. Okay, so first things first, if we want to detect the curvature of the spline, I think what we really want to do is just like get the spline anchor ahead. Let's just get the spline transform. We'll do the spline distance plus, I don't know, let's look like a half a second into the future, right? So, generally speaking, when you're measuring curvature, you're talking about the cross product. So, we'll take the cross product of our current spline direction and the direction it will be. This like caret. This little caret symbol here is the Unreal like overload for cross product. And then I have made this macro called line chart. I'll show you what that does. It's pretty nice. I've computed this thing called, I've never used, yeah, that's a handy one. I mean, if you're ever computing like a torque or like trying to get the normal of a plane or something, it's pretty handy. Yeah, you can use the caret for cross product, and then am I doing it elsewhere here? Yeah, you can use the bar for dot product. So yeah, so you can see here I was like comparing the Wurm's direction and the spline's direction. I don't think you can override dot. I think dot is not an overridable operator in C++. So. Yeah, you can see if you like just whack F12, you can see it's operator GERT. This is the thing that C++ lets you do. Anyway, if I say show charts and then I hit play, we can see this like graph at the bottom here, which is like measuring that spline curvature.size value that I was interested in. And according to this, it's like 0.1. So that's, in case you don't know whatchamacallit, the cross product, the magnitude of the cross product of two vectors is the product of their magnitudes. These are both unit vectors, so that's both 1, and then the sine of the angle between them. So that 0.1 means that the sine of the angle of curvature is equal to 0.1. I think we could come in here and say like arc sine or a sine. Now if we do it, it's still saying 0.1. That's this line chart a native function? No, this is a function that I added. So you can see it's internally calling a star HUD record sample, and then it's stringifying the expression. That's how the code that I wrote is actually showing up like in my graph. And then it's also just sending that expression in. And then each of these expressions, the expression acts as a key in a dictionary that this record sample goes into, and then my special HUD class, star HUD, is actually drawing the line chart. So it's pretty handy. There's like a number of just like quick debug things that I always add to a new project. But yeah, if you look at record sample, it's just doing, it's adding to this, I have this thing called the HUD like name to history thing. And then somewhere down here, yeah, you can see here it's like doing all the blah 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 code to actually draw that graph. So here, if we say fmath radians 2 degrees of the arc sine of the cross product, this should give me, yeah, so every, what did I call this? The look ahead was 0.5 seconds. So basically what's happening here is every half second this character is rotating by 5 degrees. It's rotating 5 degrees per second. That's like the curvature of the spline. And actually, we don't really care about the left, right. We only care about the like up, down. So we can actually just say curvature.z, and that'll give us the signed direction. Like, are we turning to the right or turning to the left? Right now we're like always turning to the right, so it should always be positive because Unreal's left-handed. Let's make sure that's right. Yeah. But if I go in here and I like start moving this, so I'll move to the right and then it will move to the left. We'll make some warbly stuff. Oh, I actually need to play the game to see my graph. But so yeah, now it's curving at like 2 degrees per second. Some really heinous stuff is happening that I don't like. But then you can see it sped up really fast. Now it's gone to 0. Now he's steering in the other direction. It's weird that he seems to like speed up and slow down on these turns. I wonder why that is. Anyway, we should be able to take this value we'll leave it in radians, and then we're just going to convert that to a twist here. So fplot we're going to say that 15 degrees is the max that you can twist, Oh. Get out of here. So now, oh, I can just look at this and simulate. But he should be kind of leaning into turns. It's a property that lets me see debug draw. This spline show flag is set. Still not seeing it. He's not perfectly straight up and down, he's like twisting a little bit. Maybe if we like look ahead more. Like look a full second into the future to measure the curvature. Man, it's wild how really ugly this got. I wonder why that is. Well, we've reached 4 o'clock, so you all don't need to watch me debug why this was looking really good and now it's looking really ugly. Cool beans. Wait, let me just see. Pass filter that's messing it up. It seems to be since you modified the curve. I make it like less frequent, is that better? Oh, you mean modified the spline path. Yeah, maybe. It's all very weird. Look how nice this is. See, he's gonna like turn in this direction. And he's like twisting like into that turn now. I like that. That's a lot better than just being perfectly upright. So I think this is basically looking good. I just gotta do some like fine tuning. But it's good for like a wander state. So maybe there's like a bunch of these loops throughout the level, and then there will be some code that like takes you from one to one. But what if I invert the twist, by the way? What if it's negative curvature angle? I think it's actually tilting away from turns right now, and I want you to tilt into turns. let's just get our little guy down here. Start imagining what this game will be like. Like, oh, it goes underground, but then it comes up again. And like, maybe their like weak point is under its jaw. So you just gotta anticipate. It's like, oh, it's gonna come up over here. There'll be big particles. Whoosh. My visualizer's off. I can't actually stand on that. It's too steep. What the character should be? I don't know. My slope limit's 45 degrees. But whatever. This is cool. This is going to be a cool video game. Okay, anyway. That was a great stream. Thanks for everybody hanging out. Apologize for anyone who was turned off by programmer talk. I can't help myself. But yeah, we took that break for GAC for 2 weeks, but now we're back, baby. So we should be having streams for the next few Fridays until later next month, in which I'm going on my honeymoon. So I will not be streaming from our undisclosed romantic location. But yeah, until then, we're gonna keep working on this stuff. You can follow us on Twitter. I'll post a bunch of like update stuff as as we like make some additional progress on this Wurm and that scorpion and this like canyon and those wasps, and like just start to get more elements of the desert level put together, which I think is becoming the like stuff I work on stream, just so it's more coherent. But yeah, you can follow us on Twitter. You can follow us on, I think we have a TikTok account. I think we have an Instagram account. Also, like, this stuff goes up on video on demand for like 2 weeks or something, but we also archive them on YouTube if you want to go back and watch any of our old videos. I don't know if I remembered to update the number correctly, but I think this is our 18th stream. I don't know. We'll see. But great. Thanks for hanging out, and I'll see you next week, or in cyberspace, or on our Discord, or wherever. Bye.